So now let us look at how we can visualize the data, right? So from a table, which is the first step, right? But actually, to keep your audience, right? You need some to visualize your data in some way. Yeah. So here, like basically, if you look at the big right table, right, you can see the length and the frequency for each class. So some smart people, right, they can see, oh, actually, you can instead of put a number, right, why don't we just put a column where the height of the column tells the frequency, right? You can see like the 7 is corresponding to this height, and here we have the class, right? The class here from 0 to 99, and you recover the boundary, you get 0 to 10, right? And basically you get 7 of them here, and you have like for this class, right? You had about 13 and 8 and 2, right? And then let us just flip, right? Flip it. So now we have something we call histogram. So it is a very powerful tool, and we use it a lot actually. And it's pretty much like the first kind of tool we think about when we look at the visualized perspective of the data. So it helps to visualize the data distribution. And here we just a graph of adjacent bars with equal width, right? And in the axis, it's just a class of quantitative data. And the Y, we have the frequency values. We call the bar heights. So here you can see that the green and peak here, instead of look at it in the table, right? We can visualize in this histogram. And here on histogram, the class boundary it help to remove the gap, right? So 0 to 10 here. I think 9995, it should be 995. But here we can also, sometimes people use 10 like this, right? 0, 10, 10, 20, 20 to 30, 30 to 40, right? But I think to make it accurate, based on the table here, it should be to 995, right? 995 and 995 to 19.95, right? So you can see that the histogram here is it really helps in a sense. It kind of make the data becomes more attractive to the audience, right? Audience, instead of just look at the table. So so the feature here, it help to shape the center, right? You can look, when you look at data, you see where center of the data, how spread it is, right? So this data, it seemingly doesn't spread much. And outliers, outliers, right? So say if you have maybe one being a big, where the teeth length maybe say 100 millimeter or something. But in this case, then I don't see this kind of phenomenon. Another modified version we can do is that we can use frequency polygon. So basically, like instead of you look at the the whole chunk of block here, you just take one point. Okay. So for the midpoint is about 5 here, right? Well, given this histogram, and you have 7, right? So basically you take the height here, so which is this point, right? And then to this guy, right? About 15, right? And then 25 and then 35. And then you connect together, right? So this is another modified version. So instead of you look at the whole chart and the whole graph here, right? The whole bar here. You look at the midpoint and you connect them. This is called a polygon. It also tells you pretty much the same story like the histogram, right? But in a similar way of visualize. And basically, like with your TI-84, if you follow this procedure by using this these steps, okay, you can also create a histogram on your TI-84. But in reality, for sure, people will use some kind of software, right? At least the Excel, eventually R, Python, which is a little bit more advanced programming language. So now we discuss about the common shapes of distribution, histogram, right? Histogram. So here, like just several common shape you may see in for the real data. So for example, here like you have the we call this we call bell shape and normal distribution. Thing is kind of symmetric. High in the middle, low at the two end. Okay. Here we call uniform, so which is thing is kind of doesn't show any kind of pattern. Thing pretty much kind of the same. So this thing like if you toss a die, right? And basically the change you get each, and you keep track number of maybe you toss maybe 1,000 times, right? And you keep track number of 1, 2, 3, 4, 5, 6 show up, right? So you should expect like the bar for each case will be relatively the same, right? Given we have a fair die. And though here we call skew to the right distribution type. So I didn't believe this data about the the um, the income per hour. Okay, so most people have a low income, but some get very big kind of a high amount of income, right? $65 an hour or something. And here, like we call it left skew to the left. Okay, so you have a long tail from the left side. So here, this age people diagnosis with cancer. Right? So we don't have much children get cancer, right? But more people get cancer at the late stage, right? So now we look at each of these more in more detail. Again, here for the normal, right? Here the weight of newborn baby in the US here. You see that the center here is high, right? Most of babies weight about 7.4 to 7.8, something like that, right? In middle trend. And you have some in the left side, which is about 6.7 and below, and from some in the high side, right? But it pretty much like it's a symmetric, right? Start low, high, middle, and low at the end. So this is called normal distribution, a bell shape, Gaussian distribution, different way of calling it. Gaussian is the name of the famous, I would say, the king of the mathematics world, Gauss in Germany. So the skewness here, we have two cases, right? Which is, the data is skewed more to one side. For right skew, and sometimes we call positive skew. So basically in this case, right, we have long right tail, right? Long right tail. So most of the value on the left side here, but some here, right? On the right. And the left skew, which is I would call negative skew, we call long when they have long left tail, right? So again, this is the age people diagnosis with cancer, right? Age. So let's look at the quiz together. Histogram represents the number of television sets per household for a sample of US household in this figure, okay? So people with one TV is 20 household, right? With two TV, we have 50, three TVs, we have 15, four, we have 10, and five, we have 5. How many households are represented, right? So for this question, so just look at the quiz, private part, okay? How many households are represented? So it's simple, right? We just add up, right? 20 plus 50 plus 15 plus 5 and plus 10. So if you do this calculation, it gives you 20 plus 50, you have 70. 70 plus 15, you get 85. 85 plus 10, you have 90, 95, right? 95 plus 5, you get 100, right? 20, 100, right? 100. So this just add up, right? Add up, you got 100. Describe the shape of the distribution in the graph here. So given we have normal, right? We have skew to the right, we have skew to the left, and we have uniform. So this should be uniform, right? Because I think the bar height is quite different. It shouldn't be normal, right? It's not symmetric here. It kind of look like the third panel here, which is skewed to the right, right? So Moses family have, one or two, right? But there's some, right? With 5 here. So this is the right skew, right? Right skew. And so you circle right skew here. how many TV sets that household has with the highest frequency. So in this case, you can look at the highest frequency. We have two, right? 50 here. So which is two, right? Two. So now we will look at other data visualization tools. So the first tool, which is also very powerful, is called dot plot. Okay, so it helps to show the distribution of quantitative data. Here we have data plotted as dots. This is what we call dot plot, right? And then we use stack the equal values together. And feature is that like it's also similar to a histogram. Uh, Yeah, but it's better in histogram in the sense, sometimes you can look at the original data value. So for example, like in the Guinea big data, right? For example, here you see you have 7 Guinea big belong to class 0 to 10 here. But if you just look at the histogram, you don't know exactly what is each value, right? You just know like 7 of them belong to 0 to 10. But with this dot plot, you can see a little more, right? So for example, it's a dot plot about the post rate of males. You can see that if you look at here, you can see that, okay, we have about two people with the post rate 50, right? One dot, two dot. Maybe say a post rate as 60, right? You have maybe 1, 2, 3, 4, 5, 6, 7, right? Seven people post rate 60, and so on, right? But it does review kind of, pretty much like what the histogram tells us. But the useful here is it's just most useful would be for small data sets. For large data set, maybe say 30,000 push rate, and you don't want to mess with this kind of dot plot, right? Histogram still better. Another different version is called stem plot, a modified version of the dot plot. Okay, it does tell you what the dot plot tell you, but it do a better job in a sense, it can help you to see exactly what each value is. So for example, like here in a dot plot, right? Sometimes it's very tricky to find out uh, what is this value, right? For example, this chunk, right? It is 51 or 52, 53, right? But if you instead of represent the data, right, in the dot plot, you use the stem and leaf plot here. You can see, okay, we got like 250 here. So in this we call the stem, okay? This called a stem. And this called the leaf, okay, leaf. So in this case, we have the one observation of 40, one is 42, so which is the two pole race, one is 40 and one is 42, and the same thing, right? Uh, we have pole rate 50, two of them 50, 50. 52, we have 1, 2, 3, 4, 5, right? 5, 52, and then so on, 54, 56, and 58, right? 56, we have two 56, right? And 58, we have 1, 2, 3, 4, 5, 6, 7, 8, 58, right? And so on, so on. So it does show the accurate data points of small data, right? And then we have a bar graph, which it helps to depict the frequency of a category of data, category of categorical data. We have the x-axis is the categories, the y-axis is the frequency of each category. We did see it right in the first chapter when we just do a quick look about how we can represent the qualitative data, right? So here again, this dot plot is about this bar graph is about the type of sports like the students prefer, right? So say here is a way we 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 want to do before we build a new sport complex, right, in the university. So the feature here it helps to review the frequency of categories, and then it also very helpful to show frequency for a small number of categories. And then the Pareto chart, right? So here, like pretty much like it's a kind of bar chart, but it reorganized in a fashion where the most important category come first. So it helped to highlight, right, the attention to draw the attention to the most important category. So in x-axis will be categories, and y-axis will be the frequency of each categories. So this is the Barota chart for the late arrival, reported by robotic calls, right? So we have people reported the reason they late for work by traffic, childcare, public transportation, weather, oversleep, and emergency, right? So from here you can see that the most important category is the traffic, right? About 32%, right? And then a childcare, which contributed to the second kind of reason, right? Is about 28% or something. I believe 28, right? You go here, right? And there's public transportation, and we do have other category. And sometimes we also see this kind of line, right? And kind of the dot, basically, it helps to add up the cumulative one. So traffic is about 38, and with childcare, two of them will add up to this much, right? About 60 something. And then with public transportation, it add up to 80%, right? So maybe we can see that, and just the first three categories add up about 80% of all the reasons people come late, right? The pie donut chart again, pretty much what happened with the quality data, right? We saw before, like it helped to depict the percent of categories in categorical data by slice, right? So each slice will have the size of each slice will represent how much each category contribute, right? And it's a very popular choice for meetings, conferences, right? And here again, we have two examples, one for electric cell share market with a donut chart. You can see the Tesla Model S, right? It's about 39% for a donut chart here. Then Chevrolet and Nissan, it kind of tie 16 and 15%, and so on, okay? And the pie chart here for the percentage of stolen boat in California, in Florida. So most stolen boat come from jet ski, blue in this, which is the biggest segment, which is blue here, about almost 50%, right? Probably 40 something in a motorboat, and then the third one will be fishing boat and sailboat, which is the smallest segment, right? And another effective tool is a scatter plot, where people try to look at the relative position of one variable compared to another, and each dot here is a pair of measurements. So the feature here, we will have to show the relation of two variables, and then it's a very powerful kind of plot, right? It helps to in a lot of prediction studies, we need to look at this, right, to see how things affect each other, right? Or maybe when you study the correlation between different factors, right? So here in this plot, we look at the average temperature, daily temperature, and the number of visitors in a beach, right? So it's important because it helps, right, you to build a model, to prepare in terms of you make ice cream, food, right? If you are a vendor at that beach, right? Our staff in terms of we collect the trash, and it will help to optimize the revenue, right? Revenue, and the staff appropriately depends on the temperature, right? And then we have another version, another kind of plot we call line graph plot, line plot, right? So here, like when our data are not too dense, okay, and sometimes people also connect the dots of scatter plot, and and this will give you line plot. And the reason people do that is that they want to review the trend to see what happening, right? So in this figure, you can see that on the left-hand side is the weight of the car, okay, and the on the x-axis, and y-axis will be the miles per gallon the car can run, right? Which we call gas efficiency. So for we want more miles, right, in per gallon, right? But you should know that because if the car weight, the car weighs more, right? Often mm, one of the thing is that if you can run less miles, right? So here, like you can plot that, right? And by using the scatter plot. So for example, this is the first here, right? And the weight is about 2.4 times 1. So with 2,400 pounds, right? It can drive about like 22.5 miles per gallon. And basically here you can see the 3.6, which is 3,600 pounds. It can drive about less than 15 miles per gallon, and so on, right? So this is a scatter plot in the left-hand side, but if you connect the dot, right? Connect the dot, you can see that you can see the trend, and the trend start to reveal to you, which is, the car weight heavier, it will, can drive, the gas efficiency be lower, right? Which is also something we expect. Even though in this data we have some data point which did not really follow the chunk, maybe the car just a new kind of model, or it's got some exceptional well, but more or less, the trend is that the heavier the car is, the less miles per gallon it can drive, right? Can drive. And then time series graph, which is a special case of line graph where in x-axis is the time, and y is the data value, and it helps to review the trends over time, right? So this is a very powerful tool in economic, right? So you can see here the SB 500 for a period, where you can see the average is different, right, for different time.